The ammonia absorption refrigeration cycle. The ammonia absorption refrigeration cycle differs from the vapor compression cycle. Vapor compression cycle in the manner in which compression is achieved. In the absorption cycle, the low pressure ammonia vapor is absorbed in water. The low pressure ammonia vapor is absorbed in water. And the liquid solution is pumped to a high pressure by a liquid pump. By a liquid pump. This picture provides the schematic arrangement of essential elements of such a system. According to this picture, the low pressure ammonia vapor leaving the evaporator enters the absorber, where it is absorbed in the weak ammonia solution. This point, low pressure ammonia vapor leaving the evaporator enters the absorber. This process takes place at a temperature slightly higher than of the surrounding. It must be transferred to the surrounding as shown. This picture. During this process, the strong ammonia solution is then pumped through a heat exchanger to the generator with the work input. Strong ammonia solution going to the heat exchanger and goes to the generator here. Where a high pressure and temperature are maintained. High pressure, high temperature, as shown in the line. Under these conditions, ammonia vapor is derived from the solution as heat is transferred from a high temperature source. The ammonia vapor goes to the condenser at this point, where it is condensed as in a vapor compression system, and then the expansion valve and evaporator completed the cycle. The weak ammonia solution is returned to the absorber through the heat exchanger. The distinctive feature of absorption system is that very little work input is required. because the pumping process involves a liquid. This follows from the fact that for a reversible steady-state process with negligible change in kinetic and potential energy, the work is equals to and the specific volume of the liquid is much less than the specific volume of the vapor. However, a relatively high temperature source of heat must be available. There is more equipment in an absorption system than in a vapor compression system. And it can usually be economically justified only when a suitable source of heat is available that would otherwise be wasted. A suitable source of heat available. In recent years, the absorption cycle has been given increased attention in connection with alternative energy sources, for example, solar energy or supply of geothermal energy. Solar energy, geothermal energy. It should also be pointed out that other working fluid combinations have been used successfully in the absorption cycle, one being lithium bromide in water, or lithium bromide. And working fluid also. The absorption cycle re-emphasizes the important principle that since the shaft works in a reversible steady-state process with negligible change in kinetic and potential energy calculated from the relation here, a compression process should take place with the smallest possible specific volume.